Okay, so task 7. And task 7 wants us to, this is really referred to as key limiting factor analysis. I mean, you might have seen key limiting factor analysis where we are restricted by the amount of kilograms of and inputs that we have, um, kilograms in this case, and we have to make the best use of that resource. So the argument is that in the short term, this is short-term decision making, we want to produce those items that give us the greatest contribution per limiting factor. That's the point here. Whoever gives us the greatest contribution per limiting factor, we make that product. And when we now have extra resource, we can just do what we like. So our ultimate goal is to find that out. Now, let's do that first. We're told we have a specific fixer, so we'll need this at the end, but we can ignore that for now. So let's just get rid of all of this, just so that I have space. And let's just fill in the table, I think, first of all, is the starting point, isn't it? Is the best place to start with all of this. Um, so first of all, I'm told you have information here that's very helpful. It says you need, for example, it tells you what you know you don't have enough because you need 800 plus 480 plus 720. Add all these together, you get two 2,000 kilograms. You only have 1,600 kilograms. So that's how you know that you don't have enough, right? Because if you were to meet all of demand, you would need 2,000 kilograms. Okay, great. So let's do this. So we need 800 kilograms here, 800 kilograms to make 400 units. So I know I therefore need to make one of these, I need 2 kilograms. So I need 2 kilograms. So I'm basically dividing 800 by 400. And 480 divided by 600, 480 divided by 600, 480 divided by 600 gives me 0.8 kilograms. And the same thing applies here, 720 divided by 400, 720 divided by 400 is equal to 1.8 kilograms. Okay, right. Now, just give ourselves some, clean this up. We've done that first one. So we now can work out what the contribution is, if you like, per kilogram. It's £4 selling price. Variable is £1.50. So contribution is £2.50, isn't it? Here contribution is £2.60, and here contribution is £2.70, isn't it? Um, no, sorry, I mean, be careful. Let's get this be careful here. What is it? So contribution here is one, so easy to make a mistake there. Contribution here is £1.60, isn't it? It's £2.70 here. So contribution here, £2.50, £1.60, £2.70. Yeah, that's very important. So now we can find what the contribution is per kilogram. How much contribution does each kilogram yield? So that would be £2.50 divided by 2 here, and that's £1.25 per kilogram. Then you have £1.60 divided by 0.8, which is 2. So you have £2 for every kilogram of investment. And then you have £2.70 divided by 1.8, and you have 1.5. 1.5 for every kilogram of investment. I'll just change my pen color. Will come blue. So if I'm ranking this, I'm going to make product Y first, then product Z, and then product X. So let's do that. I have 1,600 kilograms available. I will first of all make, like I say, product Y, and so I'll use 480 kilograms and make all my units, which is 600. So I'm going to make my 600 units. Thank you very much. And then I'm going to make product X. I will use up the 700, sorry, product Z. I will use the 720 kilograms and make the 400 units. Thank you very much. And adding these two together, 0, 0, 12, it means that you've used 1,200 kilograms. You have a total of 16, so you have 400 kilograms left to make product X. Product X. You need 2 kilograms each to make each unit, so therefore you can only make 200 units of product X. Great, and that's your table done. The next question goes on to ask us to assess the maximum profit. So I'm just going to come back here and give myself some space to do that. Just clean up everything again. And I mean, I have the contribution for each, for how this works, don't I? So I mean, so just sort of working through the gears, if I create a table, X, Y, and Z, and I'm doing 200 units, 600 units, 400 units, so those are the units, then I know the contribution. The contribution is £2.50, £1.60, £2.70. Well, I can get total contribution, can't I, by multiplying the two. So I have 500 here. 600 times £1.60 is 960, and 400 times £2.70 is 1080. So I can add all these together. So add all these together, and you will have 500 plus 960 plus 1080 is 25. You have a total of 2540. Take off your fixed costs. I'll just change my pen color. You're told you have a fixed cost of 755, and you have an answer 755 of 1785, and that's your answer, 1785. Your profit. Right. Now, the final part of that question goes on to ask us, why can't we fill demand, discuss that, analyze the demand issues, and have some calculations? Now, great question, because first of all, they're asking you to just sort of show that actually, look, I actually need 2,000 kilograms. So highlight that. Listen, you need 2,000 kilograms. You don't have 2,000 kilograms. You only have 1,600 kilograms. Step one. That's your first problem. So because of that, any other route you decide to take is the argument. Will it give you the highest contribution in this short time? Remember, we're just really focused on contribution in the short term. So we can test it. You can be as creative as you want. You will not get this current total contribution that you have here of 2540. You can just test it. Let's test it, and you can show the examiner by actually carrying out a test. So what you can keep the contribution there. You can say, okay, listen, what I'm going to do is I'm going to do it based on the person that's given me the highest contribution. So I will make, you could, again, feel free, but just show the examiner something. So this is a good idea. You could say something like, okay, listen, I'm going to make Z first. So Z, you would make Z, and that's 400 units. So Z will be 400. You make Z, which is 400 units. So if you make Z first, you'd have used 720 kilograms. Then you can say, I'm going to make all of X because that gives me the next highest contribution. So you're going to use all of the 800. So you're going to make 400 units of X. So if you did 720 plus 800, that's 20. That's 15,000. Sorry, 1520. You need 1600. You need 1600 kilograms. So that means you have 80 kilograms left to make Y. Remember that Y needs 0.8 kilograms a unit. So that means you can make 100 units of Y, can't you? So you can make 100 units of Y. Well, let's work out the contributions for these. Let's work out what the contribution for each of these is, right? So you have contribution. So 400, of course, times £2.50. 400 times £2.50. Sorry, why did I clean that out? That was just the same thing. 2.5, £1.60, £2.70. 400 times 2.5 is 1,000. £1.60 times 100 is 160. And 400 times £2.70 is 1,080. Add these three together, and what you will get 2,240. That's what you have. Right, and it doesn't really matter what you do. You could try another permutation, but this probably was your best argument that I might as well try and make it based on who's giving me the highest contribution. And that's how you deal with this question. I think you could play around with that and show the examiner that you recognize that you're not going to get more than this. But you can also argue, I think, for extra marks, what you want to tell the examiner is, listen, this is optimal behavior. Most of the time, clients, we do not have that much control. We have to satisfy certain requirements. Some of the questions in the exam kit show you being forced to actually deliver on certain requirements, and then whatever you have left, you may then follow an optimal production pattern. But sometimes you are tied into contracts to deliver, and you don't want to upset customers. Remember, this is all very much about short-term decision making, and once you do get your stocks back up to level, you can then produce, um, if you like, and satisfy all of your demand. Okay, great stuff.